Let's see one more problem from linear differential equation with constant coefficient. Now again, if you look at the RHS, it is not something as common as cos AX, sin AX, or e power AX or e power AX into some function of X. So we'll use the general one, general formula for particular integral. You all know that in case the Q, which is the right hand side, equals to any function of X, then what we do is we write the particular integral as 1 upon f of d operating on q, and now we write this in the form of linear factors, so d minus alpha operating on q. Now after this step, what we do is write this as in the form of integral, so e power, whatever sign here is opposite sign, so e power alpha x integral of same sign e power minus alpha x into q dx. So this is the basic rule. Let's apply this. First of all, complementary function, so m square plus 3m plus 2 equals to 0, m square plus 2m plus m plus 2 equals to 0, m common m plus 2 plus 1 common m plus 2 equals to 0, m equals to minus 2 and minus 1. So we are getting our complementary function as real and distinct, so c1 e power minus 2x plus c2 e power minus x. Coming to the particular integral, which is 1 upon f of d, so this in terms of linear factor will be this m plus 2 into m plus 1, so I will write this as d plus 1 into d plus 2 and operating on e power x. Okay, now just manipulate denominator and write it in numerator, so I can write this in numerator as d plus 2 minus d plus 1 divided by d plus 1 d plus 2 operating on e power x. Now this is d cancel, 2 minus 1 is 1, so no change in numerator. Now this divided by this is 1 upon d plus 1, let it operate on e power x, minus 1 upon d plus 2, let it operate in e power x. Now okay, so we are here. Now we'll use the rule. So this can be written as, if I want to use the formula, write this in a better way, so d minus minus 1 and e power x minus 1 upon d minus minus 2 operating on e power x. So 1 upon d minus alpha, 1 upon d minus alpha. So what we write, e power alpha x. Okay, so alpha here is minus 1, so minus x integral of e power opposite of this. So if here we have minus x, it will have x here, qx, which is e power x dx, minus here e power minus 2x, opposite of this will be e power 2x operating on e power x, and then the dx. So easy looking integrals. First integral, if you look, then in this integral, if you take e power x as t in I1, if you take e power x as t, so e power x dx will become dt, so this will become dt, so you'll get e power t dt. So e power, integration of e power t is e power t only plus c, so e power x is what you are getting from the first integral. So on solving this, I am getting e power x. Okay, now coming to the second one, here you can write this in the form of this, e power x as it is, Now this e power 2x can be written as e power x into e power x dx. Now if I take e power x as t, let e power x as t, t uv, because t already assumed one time in this problem. So e power x dx equals to du. Now this will become du, so our integral will convert to e power u into du. Now according to Eilert, exponential comes at last, so second function, first function. First function as it is, integration of e power u is e power u only. Let's do the by part first, then we'll write the value of u. So first function as it is, integration of second function minus integral of derivative of first function u with respect to du, that will be 1 into integration of e power u is e power u du. So u e power u minus e power u, this is what you are getting. So e power u minus 1, and what was your u? It was e power x minus 1. So this is what you are getting. So you are getting e power x, and inside you are getting e power x minus 1. So we'll simplify this. Let this remain as it is. Here what we can do is multiply this 3 terms, so you will get minus e power minus 2x, and multiply with this, so plus x, and then multiply with e power x. In case of here, minus minus plus e power ex into e power minus 2x, minus 1 into this. So I think this is e power minus x into e power x, and this is a positive one, so this gets cancelled. So you are finally left with e power minus 2x into e power x. This is your particular integral. You have got your complementary function also. So y is basically cf plus pi. So your cf was c1 e power minus 2x plus c2 e power minus x plus the pi, which you got as e power minus 2x into e power x. So a easy one. In case you remember the rule, complementary function was all easy, just a partial fraction and some by parts as well. Thanks and have a nice day.